Hello Math 1040 students, I wanted to record another video to help you with the second part of the tuberculosis project. When you're on your home page for your statistics class, you can scroll down and click on Statistics Projects Part 2 in order to access Part 2 of the tuberculosis project. When you open that tab, you will see that you have 6 tasks that you need to do. 3 that will involve creating confidence intervals and another 3 that will involve working with the hypothesis test. For the first part, what you're going to do is select 2 of your 10 random countries that you selected from part 1 of the project. However, I do stipulate that I would ask you not to choose the one that you made a simulation for in part 1 of the project. So, for example, if you go to your tuberculosis profile page, you can access this page again by going to part 1 of the project. I've chosen to look at Czechia. According to the instructions of the project, we're going to first check the conditions for the confidence interval. Remember that there are 3 conditions that are here. First is that we have chosen them randomly, which we should have. Second, you want to verify independence, and you could check that to make sure the sample size is smaller than 5% of the population. And you also want to make sure that you'll have enough successes and failures. You could check that by doing n times p to ensure that's greater than or equal to 10, and check that n times p, or 1 minus p rather, is also greater than or equal to 10. In terms of what we're working with in terms of the sample size, for example for Czechia, I'm going to scroll down and look at where we found the tuberculosis success rate earlier. We did this for part 1 of the project. The cohort size is what I will count as my sample size, in comparison to the population size, which, if I'm trying to compare this to the rest of the world would be the population size. Think about that for the second condition. For the third condition, to make sure that we have enough successes and failures in my sample size, I'm going to take my success rate that we indicated, 67%, and multiply that by the cohort. That'll be how many successes we have. If I have 67% of success, I likewise will have 100 minus 67, or 33% chance of failure. If I check those calculations, 0.67 times our cohort size of 422, I have 22.74, which is bigger than 10. And if I do 33% times 422, I also have 139 failures. So I have more than 10 successes and more than 10 failures. So everything looks good for me. Remember that you will do this for 2 of your 10 random countries, but remember not to do the one that you made a simulation for. For part B, you will then compute and interpret a confidence interval for both of those 2 countries you used in part A. Show your work and the technology inputs you used. When you're in GeoGebra, we will have a section here in the statistics section. If you go to the probability calculator that brings up the normal curve and you click on the statistics tab, you can then select Z estimate of a proportion to come up with a confidence level and confidence interval for the values in question. For example, here for Czechia, I want to make a 95% confidence interval, so I'll keep this as 0.95. And my successes out of my sample size, well, I know my sample size is 422 for Czechia. My successes we calculated over here on the right as 282.74. I will simply round that up to 283. So I had about 283 successes out of 422 failures. This gives me a confidence interval that goes from 0.6258 up to 0.7155. Note that that is surrounding the point estimate, which was the success for Czechia of 67%. We even see the interval also demonstrated here, 67% plus or minus about 4 or 5%. This would be my interval, and you would want to take a picture of this and include that into your project. That would be how you would show your inputs and calculations. You are going to do that for both of your countries. For part C, you will recall that in the first part of the project, we discussed that 85% was the global threshold for successful treatment of tuberculosis. Your question is going to be, does 85% seem like a likely value in the confidence intervals you just created? For example, for me, my interval was from about 63% to about 72%. Unfortunately, 85% is not a value within that interval. So I would say, no, 85% does not seem like a likely value. This is adding evidence to the fact that 85% is probably not an accurate claim for Czechia. Perhaps their rate of tuberculosis treatment is different than the global threshold. You will do that for both of your countries you select. For D, you will then use the country you did in part 1 to make the simulation. In part 1, you made a simulation and did kind of a hypothesis test, where we did a simulation around null distribution of 0.85 and tried to see how likely the value from your selected country was. Using that same country, you're going to do a full hypothesis test. But first for part D, you're going to check the conditions. For example, if I have another country here, maybe Guam. Guam has 80% success rate and 71 cohort. You would still want to check the conditions here, which you're still going to make sure there was a randomly selected country, which based on your work in part 1, it should have been. You want to make sure the sample size is less than the population size, less than 5% of the population anyway. And you also want to make sure that n times p and n times 1 minus p are both greater than or equal to 10. In this situation, if I do my cohort size of 71 and multiply that by my success rate, so 0.80 times 71, I get 56.8, which is greater than 10. And I can also do the failure rate, which would then be 20%, times 71, which is also greater than 10. Note that this is just barely greater than 10. This gives me 14.2. 14.2 is just a little bit above 10. If it was the fact that one or more of my conditions were to fail, then that is okay. You will still continue the project with that country. However, you will state in either part A or D, for whichever checks you're doing, you want to then state whether you will trust the values that you will calculate in the future. If you fail to confirm that we have normality because one or more of the conditions do not pass, then you should say how we start to trust our future calculations less. For part E and F, this continues the hypothesis test E asks you to complete and do the rest of your hypothesis tests, which would include making your two hypotheses around the assumed value of 0.85. These should be similar to the hypotheses that we had in part 1 of the project. Create your hypotheses, gather your data, which we have from our TB profile here, and then you can find the appropriate z-score and see how far away that is. Calculate the p-value for it. If I would like to do a hypothesis test for the country Guam that I selected, then when I look at the tuberculosis profile for it and bring up GeoGebra, I can instead select z test of a proportion to do a hypothesis test. My null hypothesis should be 0.85. P equals 0.85 is assuming the global threshold of 85%. And I choose a not equal to sign to show the two-sided test. This is very similar to what we had in part 1 of the project. However, for my successes and sample size, here we have a cohort of 71 for Guam. That's my sample size. The number of successes we calculated earlier we had 56.8, or about, I'll say, 57 successes. This gives me enough information. This tells me successes and sample size, and Z tells me that my value of 57 out of 71 is negative 1.11 standard deviations below the mean, or standard errors below the null value, with a p-value of 0.2655. If I were to do a hypothesis test for this, for example, if I choose an alpha level of 0.05, this p-value would be far too large, and therefore I would fail to reject the null hypothesis because this p-value is bigger than 0.05. Or maybe I chose 0.01. I would have the same conclusion. You should then, for part F, compare your results that you get for your full hypothesis test to the parts and results you got from part 1 of the project, where you did a null distribution simulation. Compare those, see if you get similar results, if you get a similar conclusion, talk about how similar they are or how different they are. Just like before, with the first part of the project, make sure you put all this into one document, save it as a PDF, and you should be able to submit that. If you have any questions, feel free to put those as a comment in the announcement below, or just talk to me after class or send me a message. Either way, good luck on the project.